Hello everybody. Today we're going to be looking at the Algebra Regents from June 2025. Whether you're coming to study for the one in August, or maybe you find this next year in 2026, or you're just curious on how you did on the 2025 one in this past June. We'll be going through every single question, all 35 questions, nice and in depth. Try to use some shortcuts along the way. But yeah, if you end up learning anything from this, feel free to leave a like. I'm working hard to get this out to be one of the first for the June region, so much appreciated if you could leave a like if you learned something. Um, yeah, also leave a comment if there's anything I need to go more in depth with, or in the future if you want to learn a different type of math trick, just let me know. But for now, let's get right into it. Okay, so I took screenshots of the test, so I'll just be kind of flipping through my camera roll and marking it up. There we go. So here's question one. The expression 10 over radical 2 is equivalent to. So full transparency here. If I was doing this, I would probably just grab my graphing calculator and do 10 divided by square root of 2, and then see what that would be equivalent to. It would definitely wouldn't be 5, it definitely wouldn't be 20. It's going to be an irrational number because the square root of 2 is not a perfect square. And then you can just try 5 times square root of 2 or 10 times square root of 2 and see which decimal it matches up to 10 divided by square root of 2. However, if this were a show your work, I have seen a rationalize the denominator show your work problem before. Here's what we'd want to do. So first is we need to get rid of this radical 2 in the denominator, and to make that into a rational number, if we multiply a square root times itself, that gives us the number we're trying to take the square root of. But remember, if we're multiplying a number, we have to multiply it by 1. And to multiply it by 1, that means we have to multiply by the numerator over the denominator. Square root of 2 over square root of 2 is equal to 1. So that gives us 10 radical 2 over 2. Unfortunately, it's not one of our answer choices. We have to do one more bit of simplifying, and then it's just we could do 10 divided by 2. That gives us 5, and the radical 2 left over, which is answer choice 3. Okay, to question 2. This here we have a parabola on the axis, and it's just asking us over which interval is the parabola only increasing. When you see interval, I want you to think of x values only. They're trying to kind of trick you and give you some x values and some y values, right? Trying to trip you up with domain and range. But when you're talking about the interval, that's usually just the x values. So we see here increasing would obviously, do you think it would be the functions going down from left to right, or the functions going up from left to right? Yeah, increasing. So the only time this function is increasing, if you see right here, there's a little vertex, the turning point. That is the x value of 3. And from 3 on, it is always going up, 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 up. So 3 to infinity. Infinity goes forever. Question 3. We're looking for an exponential relationship, so we're looking for either a multiplication or a division pattern. We're not looking for addition or subtraction, that would be linear. And just reading through these answer choices super quick, lose 1 pound per week, that's linear. Increase 5 points each quarter, that's linear. That's a common difference, constant rate of change. reduce spending by $50 each month. That's a constant amount. And when we look at percents, that's kind of a dead giveaway that it's going to be multiplication or division. And that's going to be an exponential function. Because 5% of last month is not the same as 5% of this month because you have more money. And that is how exponential works. It's not a common rate of change. It's, again, a multiplication or division pattern. Okay. Now remember, I'm going through this nice and slow. It's only been about 5 minutes, and we already got 3 questions done. You have 3 hours to do it on your test, and you'll probably be moving a little faster than me. So take your time. You got this. Use up all your time. Okay, so we're on to the next question here, which is question 4. The geometry test scores for Andrea and Joe are shown in the table below. Which statement about their test scores is true? So what I would probably do is just plug this right into my graphing calculator. I'm going to pull up my graphing calculator online. I probably should add this up already. Okay, and we're going to go into the stat menu. Can kind of write out the steps here for you. If it was just a mean question, even a median, I'd probably feel more comfortable doing it by hand. Since it has that annoying standard deviation, I'm just going to play it safe and plug it to my calculator. So I'm going to go stat, edit, which is option 1. And then I'm just going to plug in the numbers into my L1, this one. So 82, enter, 87, enter, 90, enter, 84. Okay, once I've entered the data, I'm going to go back to stat. I'm going to go over to calc, which is on the right. Just tab over one to the right. I'm using a TI-83 Plus, by the way. Should be pretty similar for TI-84s. I'm not sure about TI Inspire. And then just press one variable stats and enter. So I found Andrea's mean, which is this little symbol, X with a line over it. Hers was 85.75. And her standard deviation, which is this big SX, is 3.5. So now I'll just repeat the same process. I'll change the numbers to Joe's numbers, so 91, 78, 94, 67. And as I'm doing this, I can kind of already tell. So standard deviation is basically like how far apart the numbers are. And I mean, just being thorough calculating it, but you can tell Joe's numbers are way more spread out. There's a lot more variability to them. So he's going to have definitely a higher standard deviation, but let's just confirm that. So his average was 82.5, and his standard deviation is about 12.4. I rounded it off. So you can clearly see that the mean of Andrea's test score is higher, but Joe's standard deviation is higher. There you go. Again, I probably could have figured that out without a calculator because his scores are way spread out, but just to be safe, we have the time. Let's go for it. Okay. Can do question 5 and 6 here. Question 5 is a nice, easy one. Which polynomial has a degree of 3? So degree, we're just looking for the highest exponent. And leading coefficient, that means that there's going to be a 2 in front of the variable. It's going to be being multiplied in the front of the variable. So that's a real easy one. 2x to the third. That's exactly what we're looking for. Sometimes these problems aren't in standard form, but this one already is, so that's a quick one. And then number 6, so this is a subtraction of polynomials, so what I would probably do is distribute this negative and rewrite as just a combining like terms problem basically. I'd lose the parentheses on the first binomial. They don't really do anything. But the parentheses on the second, on the trinomial, really change things up because basically everything is going to flip its sign when you're subtracting. You're kind of multiplying by an invisible -1. Think of it like that. And so the 7x squared is now negative, the minus 5x is now plus, and the plus 4 is now minus 4. Then you can just combine your like terms. So you got negative 3x squared and negative 7x squared. It's going to make negative 10x squared. 5x doesn't have a like term. And then positive 9 and negative 4. That's going to make positive 5. So we're looking at, where are we? Answer choice 1. Number 7. We got a rate of change problem. Okay. This only wants us to worry about between weeks 4 and 12, sorry. So I'm going to kind of ignore the rest of the chart and just look at week 4, that the plant was 12 inches, and week 12, the plant was 60 inches. So I can just subtract the heights and the weeks, kind of like a slope problem, y2 minus y1 over x2 minus x1. And that will give me 48 over 8, which is 6 inches per week. Right? If you notice, the chart isn't going up by 6. Well, actually, it is for there, but then this next one, it's not a constant rate of change, right? But they only want us to worry about it from weeks 4 to week 12. So just focus on those in your chart. You'll be fine. Question 8. We have we have solving an equation with variables on both sides. Sorry. So we gotta try to see what they did from the given to step 1. And it looks like they subtracted 3x from both sides, and they subtracted 3 from both sides. Because I can tell the 5x became 2x, and then the 0 that the constant was originally became a -3. So we're just subtracting from both sides. That's called the subtraction property of equality. And then number 9, the absolute value function, that's the parent function. This one, just absolute value of x. So it's going to be, if we had a coordinate plane, it would just be centered. The vertex would be the origin, and it'd just be a V shape going up 1 over 1 in both directions. And we want to see which one is going to get shifted 2 units to the right. So you could plug this into your graphing calculator. If you know your rules, you should know this one's going to go up 2, your transformation rules. This one's going to go down 2. And then it's kind of just a toss-up. If you remember that minus actually moves it to the right, it's kind of opposite of what you think. It's a tricky one. But remember, you could always plug it into your graphing calculator, and you're looking for the one that would end up over here. Okay. Let's keep going. Question 10. Looks like we got a system of equations here. This is a fun one. So we want to use substitution, which means we want to solve for one of the variables, and it's pretty obvious. You have the 4x, 2x, -3y. They all have coefficients, but this y has a coefficient of 1. It's invisible, so it's really easy to work with. Basically, we're just going to subtract 4x from both sides. And then we can rewrite the first equation as y equals 5 minus 4x. So then in the second equation, we're just going to replace that same y with what it's equal to, which is 5 minus 4x. try to mark this as non-equal sign, that's a minus. And that looks like answer choice 3. Which equation is equivalent to x squared minus 6x equals 27? Oh, so this is a completing the square question, which means we need to add b over 2 squared to both sides. B is negative 6, so negative 6 divided by 2 squared, which is going to be positive 9. So we're going to add positive 9 to both sides. And right away we can cross out answer choices 4 and 3 because they're adding 36 to both sides. They must have, they're trying to get us to, well actually sorry, one's adding negative 36, but they're trying to get us to think that we have to add b squared to both sides, not b over 2 squared. Then we should know that this factors to x minus 3 squared, but that's kind of obvious because both the answer choices left factor that anyway. And we're just going to look and see plus 9. And the only reason you might have got minus 9 is when you plugged negative 6 divided by 2 squared into your calculator, or negative 3 squared maybe, you forgot parentheses because that's going to give you positive 9 in your calculator. This is going to give you, oh sorry, that's going to give you negative 9. Whoops. This is going to give you positive 9 because the calculator does exponents first, then multiplies it by this quote-unquote negative 1. But in this option, it's going to do negative 3 times negative 3, which we know is positive 9. So just really, really careful with your parentheses. All right, question 12. This is a fun one. We got a box plot. You can always count on a box plot being on the Algebra Regents. So based on the box plot, which statement is true? So right away, they're kind of giving us a freebie here. The interquartile range, as long as you know that that's from the edge of the boxes, 12 to 16, that's an interquartile range of 4. This one's same thing, 10 to 14. That's also an interquartile range of 4. So that's going to be a nice one. Answer choice 1. Just to go through the other ones super quick. A box plot doesn't tell you how many athletes there are, it just tells you their ages and the summary of their ages, so that one doesn't make any sense. The medians are the middle line, so the median of the swim team is 13 and the track is 12, and that's definitely not true. And then the range is from these little whiskers, so the range of swim is 8 and the range of track is 7. Oh, sorry. So yeah, it's answer choice 1. Okay, 13, we got a domain question. We can see, again, they're trying to trick us with domain and range, so you just got to know your vocab here that domain is x values, range is y values. So right away, 15 and 45 make no sense because they're talking about the y values. The domain is the x values, and kind of a toss-up between the two choices until you see that at 0, there's an open circle, which means 0 is not actually included in the domain. It's just like a lower limit. Basically, the domain starts infinitely small, whatever past 0. So it's got to be answer choice 3 because it doesn't have the or equal to next to, or in between 0 and x. The bracket actually does mean or equal to, so it can't be answer choice 1. Okay, and now 14. This is adding 3, well, sum, right? That's adding. So 3 plus radical 5. So 5 is not a perfect square, which means square root of 5 is irrational. And if you add 3, a rational plus an irrational, there's no way it makes a rational. It makes a rational, sorry. You could always plug this into your calculator too. And then it's kind of just like a vocab thing here. So irrational, since the sum can be expressed as a terminating decimal, well, you should know terminating decimals are always rational. So that doesn't make any sense. And I like this answer choice a lot. Irrational, since the sum cannot be expressed as terminating or repeating. It's literally the definition of an irrational number. That's gonna wrap that up nicely. At 15, we got a law of exponents problem here. So they're trying to trip us up, uh, definitely with all three of the wrong answers. For answer choices 1 and 2, you'd actually have to FOIL them. You have to double distribute them. And same with answer choice 2. You'd have to, because when if something's to the second power, it means multiply it by itself. It doesn't mean multiply the two terms by themselves. Um, so if you double distribute this, you're going to get some, sure, you'll get a to the 8th and you'll get b to the 6th, but you're going to get some middle terms like minus 2a to the 4th, b to the 3rd, I think, if I did that correctly in my head. But so you can't pick these. That's not going to work out. And then now it's just a toss up between these um, two answer choices 3 and 4 if you know your power of a power rule. Power of a power says to multiply the exponents, not add them, which is what they're trying to get us to do in answer choice 4. Oh, I think I was supposed to do 16 on this screenshot also, sorry. Okay, so again, actually I'm kind of surprised at how many square root problems are in this multiple choice, but if I was doing this, again, I might just kind of rely on my calculator, check it out. But again, if it would show your work or if you just want to know how to do it, what we want to do is we want to, I'm actually going to do this more up here. We want to simplify these radicals. You kind of think of them as almost like variables, and you can't add these to addends together because they don't have the same radical. But let's just break down 27 super quick. We know 27 is 3 times 9. And we know 12 is 3 times 4. And what's really cool about that is 9 is a perfect square and 4 is a perfect square. So you could rewrite this as 2 radical 9 times 3 plus 4 radical 4 times 3. But since 9 and 4 are perfect squares, you can take their square roots out as 2 times 3 radical 3 plus 4 times 2 radical 3, which is going to give us, running out of room, 6 radical 3 plus 8 radical 3, which is going to be 14 radical 3. Okay, 17, the sum of Tim's age and Jack's age is 44. Tim's age is 4 less than 7 times Jack's age. So 4 less than, a lot of people start with that. But that's 4 minus. 4 less than is going to be whatever is less than, take away 4 from that. 7 times the x is just going to be 7x. Then don't forget that is Tim's age, but the sum of Tim's age and Jack's age. So don't forget to add Jack's age back into that equation. And then 18. So all we have to do, you could plug this into your graphing calculator. You could plug this into the y equals and then go to the table and evaluate it at -2, see what the y value is. But I'm just going to try it by hand. So 2 to the -2 plus 3. I'm just replacing every x with -2. And that's over Don't forget to put this -2 in parentheses, that can mess you up. So now just evaluate. This becomes +1. 2 to the +1 is 2. Sorry. Um, this becomes +4. +4 minus 2 is 2, and 2 divided by 2 is 1. We're almost done with our multiple choice. Okay, I think the top of this equation, this problem got cut off, but it just basically, this is question 19, and it basically just says 4 graphs are shown below. So then we have to look at our 4 graphs, and we're trying to figure out which ones are functions. Remember, functions, x values cannot repeat. An input cannot go twice to 2 different outputs. So basically, there's a cool trick for this called the vertical line test, where if you imagine running imaginary vertical lines straight down, would they ever hit your relation more than once? And for this one, no. No x values repeat. This passes the vertical line test, and so does this. Here's a good example of a relation that fails the vertical line test in the circle. Because if you draw this vertical line, see how it hits the circle twice? But it only hit the line once. It only hit the parabola once. This is not good. That's not going to be a function. And then obviously this one is failing the vertical line test the entire time. So this one's going to be A and B only. Try to get that vertical line test down. That'll help you a lot. Oops. Okay, final stretch of multiple choice. Question 20. Don't get tripped up by this. They're giving you a bunch of science mumbo jumbo here. Not actually, but they're trying to give you this extra fluff in the problem to try to trip you up. But it's still an algebra problem. You're just trying to solve for m. So all you need to do is get m by itself. Real simple. How do you get rid of 1/2? Multiply it by 2. Let me rewrite this. Times 2 to both sides. How do you get rid of v squared? Divide by v squared. 2k over v squared. There it is. Perfect. All right. On to question 21. So this is a solving problem. Now, first we can distribute this. That's fine. And we would get 6x minus 2 over 3 equals x plus 2. Then we could divide both of these by 3 and we would get 2x minus 2/3 plus 2. Oh, sorry. Where's my eraser? Equals x plus 2. Perfect. Okay. And now we're just going to subtract x from both sides. We're going to get all the variables onto one side, all the constants onto the other. So we can add 2/3 to both sides. I'm going to finish this over here. So we already have x. This would cancel, equals 2 and 2/3. And if we do a quick little C method here, 3 times 2, because our answer choices are improper fractions, it's going to be 8/3. Also, 2 wholes is 6/3 plus the extra 2/3 is 8/3. Sweet. And there's only 3 more multiple choice. Okay. So we got a sequence here. It is geometric, and we could see that it's basically dividing by 2, but dividing by 2, just remember that's the same as multiplying by 1/2. A little keep change flip action. The first term is 12, and the common difference is 1/2. And if you multiplied 1/2 by whatever term you want, take away 1. If you want the 10th term, you do 1/2 to the 9th power and then multiply it by the initial value. So that's going to look like um, as a choice 1. That also should be on your reference sheet. AN equals A1 times R to the n minus 1. That should be on your reference sheet. And the rate is 1/2. The initial value, oops, well, the initial value is 12. Okay, 2 more. Multiple choice. So the axis of symmetry, that if you draw a vertical line down the um, down the middle of the parabola, it makes it symmetrical. So it just basically splits it in half. It always goes through the vertex. It's always the x value of the vertex. So x equals 2 would definitely not split that in half. X equals 3 would. Here it looks like the vertex is at 0, 2, which means its axis of symmetry is x equals 0. No good. Now you could plug these into your graphing calculator. There is a quick trick for this. It's actually on your reference sheet too. The axis of symmetry is x equals negative b over 2a, which would be b would be 8 and a would be 2 in this problem. So it would be negative 8 over 2 times 2. So that's going to give you actually negative 2. And this one, a is 1, b is negative 4. So it'd be negative negative 4, which is positive 4, over 2 times 1, and that would be positive 2. Again, you could always plug that into your graphing calculator, kind of look at a table like this, and see if the vertex is 2, if the turning point's at 2 comma blank. And then last, multiple choice. Okay, so I have a trick for this, is that I used this method called cross canceling. And basically what I'm doing is I'm looking for units. I'm looking for units in the denominator and the numerator. I'm looking for a pair, and then I'm going to cross it out because I just want to be left with cars per minute, and I'm starting with miles per hour. So yeah, let's check it out. Let's check what I mean by that. So right away, answer choice 1 can't work because miles and miles are both in the numerator. That's going to give you like miles squared if you end up multiplying. It's not going to cancel out the miles. And same thing with answer choice 2. Answer choice 3 looks like a good start because you have miles and miles, you have hours and hours, and you have feet and feet. So I'm going to come back to this, but I like this a lot because you just have cars and minutes left. And then we have a good start for this one too, miles and miles, but hours and hours, that's not good. It's got to be answer choice 3. And we're done with the multiple choice. On to the constructed response. So there's multiple ways to do it. I'm going to show you the way I do it, and then you can always look too on the Algebra Regents website. There's multiple solutions to each of these, multiple ways to get full credit. So check that out if the way you did it didn't exactly line up with the way I did it, but yeah, just let me know if you have any questions too. So this is a two-way frequency table. This is, I mean, as far as like a show your work problem, this is pretty fair. We should be definitely shooting for full credit on this. So if right away I'm seeing 100 student survey, that's going to go in the total. Then it says 44 were seniors. Of the 65 students who preferred to watch videos, so watch videos, 65 is the total. 42 were juniors. You actually don't need to show any work on this one, so you don't need to do 65 minus 42 down below. They're full credit, just fill out the chart. So that's going to be a 23. Um, then that's going to be 35. This is going to be 21. And this will be 14, which makes this 56. And then we just double check everything adds up. 42 plus 14 is 56. 23 plus 21 is 44. 65 plus 35 is 100. 42 plus 23 is 65. 14 and 21 make 35. And 56 and 44 make 100. Perfect. Okay, so here we have an inequality with variables on both sides. My always instinct is let's distribute right away. Now we have an inequality with variables on both sides. So what I like to do is draw a line down the middle, pick my variable side as the variable with the larger coefficient, the greater absolute value. So I like -5 as the variable side. So I'm going to add 11y to here. The reason I do that trick is because it will always give me a positive variable if I choose the variable side to be the greater absolute value. And that's especially handy for inequalities, so we get to avoid that dreaded step of remembering to flip the inequality symbol when dividing by a negative. If you want to do this all at once too, you can subtract 10 from this side, and we get 6y is greater than -18. One more step to do, divide that by 6, and we get y is greater than -3. No need to flip the symbol because we didn't divide by a negative because of that trick. Oh, and then we have a good double distribute, aka FOIL problem. 5x times -2x is going to be -10x squared. You just add the exponents, multiply the coefficients. That's going to make 35x plus 6x minus 21. And they say we need a trinomial in standard form. Don't even let that confuse you. Just simplify. Basically, that's all it's saying. So -10x squared. We can add these like terms together. Plus 41x minus 21. Perfect. Okay, so here we have sequence. I was surprised more students didn't get this one right. I'm guessing because they didn't know you can kind of just brute force and write out the list for this. So we have to find the pattern. So first off, from -2 to -20, that's a change of 18. It's going up 18 over the fourth term minus the first term over 3 terms. So the common difference is 6. So a valid way to do this is totally just adding 6, adding another 6, adding another 6, adding another 6. So we're just adding 24, and you get 22 as your answer. You get full credit for that if you show your work. I will show you the arithmetic sequence formula way to do it too, just so you have it, which is an equals a1 plus the common difference times the term you want, take away 1. So the first term is -20. The difference we determined was 6, and we want the the eighth term. So that means we're going to multiply 6 by 7, which will give us 42. Excuse me. Sorry about that. And we'd get positive 22. Perfect. Okay, almost there. This one, a bit tricky if you don't know your point slope form, but you actually can use the set of axes below. It's optional, but you can use it to help you. So I'll show you both ways actually. The first is point slope, which is y minus y1 equals m times x minus x1. And this is in your reference sheet. If you want to label, m is the slope, x1 is the x-coordinate, and y1 is the y-coordinate. So this would be y minus 5 equals negative 3 times x minus negative 2. Is it alright if I simplify that to positive 2? Keep change opposite. Right, and this is a two-step process now. Distribute and add 5 to both sides. Y equals negative 3x minus 1. That's converting point slope into slope intercept. Y equals mx plus b. If you want to do it on your, it was negative 2, 5, and negative 3. Because if you want to do it on your graph, you could do that too. Plot negative 2, negative 5. And we already know, guys, we already know that the slope is negative 3x, so we're just looking for the y-intercept. So let's just use the slope to help us. Go down 3 over 1. Down 3 over 1. There it is. The y-intercept is negative 1. There you go. And 30, the last of the 2-point questions. So, okay, factor completely. A question like this is very predictable. It's basically been on every Regents, for not every, but most. You should be prepared for it. There's always going to be 2 steps to this. Factor out a GCF, and then the difference of perfect squares, which is a squared minus b squared, split that into a plus b, a minus b. So the GCF of x cubed and negative 36x, well, they don't have a GCF coefficient, it's 1, that doesn't help us, but they do have a variable in common. So we can take out an x out of both of these. We can always take the lowest exponent out of both of these. And that factors it to x squared minus 36. And now you should be very happy because you have 2 perfect squares. X squared, that would represent a squared, so x is a, and 36 would be b squared. So 6 is b. They're square roots. So you're just going to split this into x plus 6, x minus 6. And that's it. That's full credit. Okay, so next we have a system of equations here. So negative 3x, we're going to graph. That's a linear equation. So I know that starts at the origin because there's no y-intercept written in it, so it's 0. And then that's going to go down 3 over 1, down 3 over 1. I can go up 3 and reverse it. Something like that. Try my best to make that straight. I think that's pretty good. Make sure you take up the whole graphing space they give you and put arrows. Now, this quadratic, I'm just going to play it safe, plug it into my graphing calculator, x squared plus 2. And I'm going to go to the table. I love the table. It's my favorite feature on the graph, second graph. And I'm just going to look for some points. So I see negative 2, 3, 4, 5, 6, negative 2, 6. I see, oops, what did I do? There we go. So I see negative 2, 6. Then I see negative 1, 3. Oh, then I see 0, 2. That's the vertex. Then it starts to go back up. So something like this. And I missed that point, but on your test you would hit that. And then just don't forget to label whenever you graph more than one thing on a coordinate plane. It's always good to label at least one, if not both. Okay, and that's an easy way to get a couple points. There is a follow-up question, which I had to split this up into two screenshots. But basically just asks for which x values are f of x and g of x equal. You're just looking at the intersection points. But a common mistake students were making was they were writing the coordinates, but you just want to write the x values. As you can see, state the values of x that satisfy the equation. So that's just going to be x equals -2 and x equals -1. You get 3 out of 4 if you put the coordinates, the y values also, because it's only asking you for the values of x. It's basically asking you for the values of x that make the y values equal. All right. This is going to be a fun one, quadratic formula. But we have 4 more questions. Quadratic formula, make sure you go to your reference sheet. I'm not going to write it out, but it's going to be -b. Well, actually, the first thing I would do is label A, B, C. A is 6, B is 2, and C is -1. Then we can just plug it right into our quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So you get 1 point just for that. Obviously now we have to do some work and simplify. So 2 squared will make 4. -4 times 6 times a -1 will make +4, so it would be 4 plus 24 all over 12, which would be equal to -2 plus or minus square root of 28 over 12. And now unfortunately you do not get full credit there. Sometimes they used to give it to you. But you have to simplify now into the simplest radical form. So on the side, break down 28 into what you know multiplies to it. 1 times 28, 2 times 14, but we're looking for perfect squares. It's going to be 4 times 7. There was a multiple choice like this way earlier. So it's going to be -2 plus or minus radical 4 times 7 all over 12, but we know what radical 4 is. It's 2. I don't know if my denominator got cut off, but it's 12. And you can stop there. You actually would get full credit for that. Another cool thing you could do is simplify all these by 2, divide all of them by 2. So you could do -1 plus or minus radical 7 over 6. That would also be an acceptable answer, but you don't need to do that. You just need to make sure that 28 is broken down into 2 radical 7. Okay, linear regression. Guys, that should be a free 4 points. You just need to know how to use your graphing calculator. So I can write out the steps here. Stat, edit, and don't forget actually in the very beginning when you first get your regents, you should turn your diagnostic on, which is second 0 for a catalog, and then you just scroll all the way down to diagnostic on, and then hit enter, enter done. Now you can go back to stat edit. You would input the data, so you're going to put the time since release in the x values, to L1, sorry, and the L2 is the price in dollars. As you're doing that, kind of get an idea of what's happening so you can verify it with your calculator. As the time is going up, the price is going down. So we should see some sort of negative correlation there. We're going to calculate it for ourselves. Stat calc. This time it's going to be 4 ln reg ax plus b. The x list is L1, the y list is L2. We're going to hit enter, enter, and enter, and we're going to calculate that. We're going to make sure we know how to round to the nearest hundredth. So I got y equals negative 23.67x plus 1,216. That's okay. It's a whole number. Doesn't matter. Okay, now we have two more parts to this. The correlation coefficient, remember you can only see that if you put your diagnostic on. So if you're only seeing y equals ax plus b, a equals blank, b equals blank, and you're not seeing r, that's because you did not put your diagnostic on. The correlation coefficient is just r, not r2, not r squared. And this is going to be negative 0.99. So what does that tell you? Well, it's really, really, really strong. Basically the only word you need to put in there, obviously you can show off, you can say there's a strong negative correlation between time after release and price after release. But if you get this word strong in your answer, you're going to be fine. And the reason it's so strong is because the highest on the negative side is -1. The highest on the positive side is +1. So if you get into those 0.9s, negative 0.9s, it's going to be super strong correlation coefficient. Okay, two more. They're both systems. This one's a system of equations. And what I'm thinking for this one is we should isolate y in the bottom equation. So we can rewrite it as 2x minus 6. And now, since both equations are equal to y, then they're really just equal to each other. That's called substitution. X squared plus 9x plus 4 equals 2x minus 6. Now what I'd want to do, this is a quadratic equation. I want to set it equal to 0, so I'm going to move the 2x and the positive 6 to the other side using inverse operations. That's going to give me x squared plus 7x plus 10 equals 0. And now I can factor this. I'm looking for two numbers that have multiplied to 10 and add to 7. It's going to be 5 and 2. And you can just double check. You can FOIL this. You could double distribute and make sure it gives you the original trinomial that you had up there, x squared plus 7x plus 10. Okay, so now we have a zero product property. So if you're multiplying two things and they equal 0, that means that one of them has to equal 0, at least one of them. So if x plus 5 were to equal 0, then x would have to be -5. And if x plus 2 were equal to 0, then x would have to be -2. You could just subtract 5 from both sides, subtract 2 from both sides if that leap is kind of difficult for you to make. So those are the two values of x, and now we need to get the two values of y. I can't tell if this is going to be cut off. I think it is going to be cut off. So I'm going to actually clear this and then start where I left off at -5 and -2. You would need all this for full credit, not just the last part. And then don't forget we had the equation 2x minus 6. So if x were to equal negative 5, to find y, we can plug it into either equation, but to me this second equation seems a lot easier. Y equals 2 times negative 5 minus 6, which is negative 16. So that's 1x and 1y. And then y equals 2 times, the other one was negative 2 minus 6, which is negative 4. Minus 6 is negative 10. And don't forget, x equals negative 2. So you have two pairs of x and y. We just solved it algebraically. Basically, if you graph this line and this parabola, kind of like in an earlier question, these would be where they intersect. Negative 5, comma, negative 16, and negative 2, comma, negative 10. So all we did was just solve it by hand, which is kind of cool. And the final question, we have a system of inequalities this time. It's usually a system of equations, so this kind of threw me off a bit, but that's fine. I kind of combined the system of inequalities question with the system of equations question. And we have two conditions here. We have money. We have babysitting, tutoring. Oh yeah, no, sorry. The two conditions are money and hours, time. So the first equation, let's start with the money, would be 6x plus 12y. She wants to make at least 120. Would she want to make more or less? More. Would she also be happy if she made exactly 120? Yes. So that's your money condition equation. And now your hour condition, well, x plus y, the amount of hours together, can't be, has to be under 14, or it could be exactly 14. You just got 2 points. Not bad, right? So now what I would do next, I'm a big fan of slope-intercept form. So while there's a way to graph this obviously in standard form. These are in standard form. I like slope-intercept form. That's my favorite form to graph. So what I would do is isolate y. This would probably just be on the side. Um, you know, you don't want to mess with your system that you already got credit for. You're just rewriting it. So the first equation is negative x plus 14. The other one, a bit trickier. You'd have to subtract 6x from both sides. So you get 12y is greater than or equal to negative 6x plus 120. Then you divide by 12. So you get y is greater than or equal to negative 1/2 x plus 10. Okay, let me just write these down on a sticky so I don't lose them when I graph them. Because in the second part, this is a 3-part question, a 6-point question. We're going to have to graph both of these. So let's do it. Okay, so I'll graph the first one. It has a y-intercept of 10, and it goes down 1 hour of tutoring for every 2 hours of babysitting. Something like this. Oops. We actually don't need arrows because hours cannot go into the negatives. And we'll draw a nice straight solid line because it was or equal to. And then I like to shade at the end. Don't worry, I won't forget about it. But I like to shade once I have the two equations graphed first. Then the other one starts at 14, and this one goes down 1 over 1. getting a little mixed up here, sorry. Beautiful. Sort of. Oh boy. Okay. Don't forget to label. So this one was the, oops, this one. There we go. Don't do what I just did. Don't lose steam at the end. Okay. Then we got a shade. So we will shade the, oh wait, I did flip that around. Sorry. I will, I will take this extra time here to fix that. This one, just negative x plus 14. So I kind of have a vision in my head here for shading. I'm going to shade this one below. Okay, yes, I shaded that right, and then I got the label wrong again. This one started at 10. Sorry. That's why it's important to take your time. So this one I shaded below, and then this one I will shade above. Perfect. And you can see this little overlapping area is where the solution is. And then lastly, it's just going to ask us for a combination of hours that worked. So anything in the shaded area is fine. There's a bunch of points to choose from. Maybe I'll pick this one right here, which is 1 hour of babysitting and 12 hours of tutoring. And 12 hours of tutoring. Nice full sentences on the Regents. Don't forget. Justify your answer because it is in the double shaded region. You could also do it algebraically too. You could do 1 times her babysitting rate plus 12 times her tutoring rate and make sure it's at least her money goal, and then obviously add the 1 plus 12 and make sure it's under her time goal. But okay, we wrapped that up in a little over an hour. So remember, you have 2 extra hours to do it. So take your time. Don't rush. You'll get there. Yeah. Again, this was a decent amount of work to set up and coordinate with my iPad and everything. So if you could support, that'd be much appreciated. And let me know what you want to see next. Thanks.